notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018-2027, schedule of videos. These three sections, 1, 2, and 3, a total of 51 videos, have been published on YouTube in their entirety. Please make good use of them. Section 4, measurement. All 17 of these videos completed, and 5 are published in their entirety on YouTube. We are now at section 5, statistics. This is the first of 17 videos, and we are behind schedule. After that, we have algebra to do, and then section 7, relations, functions, and graphs. Section 8, geometry and trigonometry. And section 9, vectors and matrices. Hopefully, we'll get that done by May 2025. However, disclaimer, this schedule is just a projection which may or may not be fulfilled. It is not a contract, and right now, it doesn't look like we finish this in May 2025. Reminder that section 1 has 33 videos, and they are all available on YouTube. These videos form the foundation on which the rest of the syllabus is based. Please make sure you look at all of them and know them very well. Another reminder, you will need to know the times tables from 2 to 12. If you already know them, fine. If not, you will have to learn them, especially since calculators are not allowed in paper 1 of this exam. From section 2, all 12 of those videos have been published in their entirety on YouTube. From section 3, all 6 of these videos published on YouTube in their entirety. And section 4 that deals with measurement, these have been published on YouTube in their entirety, these 5 that you see here, that one, and so on. And these others are only published partially, video 2 and video 3 and so on. We are now at section 5, statistics. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions. CSEC recommends these in its syllabus, these that you see here. From that, I would recommend a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC questions by Raymond Tulsi. And this is a picture over here of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. That is to say, all questions from paper 2. If you have a question that you still need explained, you can ask AI assistant by either text or voice, and most likely that will be explained. This is the URL that you see here. And on the next slide, I will show you the home page of that RSC website. So this is the home page. You will have to register first, and subsequently you would sign in. Again, this is the URL. I will post that URL in the description in this video, so it will be easy for you to get at this website. Now, this is just a reminder of the formula sheet that will be provided for you during your examinations, papers 1, 2, and 3, if you are doing alternative to the practical. Here you could see the top part of that formula sheet, and this is the below part. That means that you don't have to memorize these formulae. Just make sure you know when to use them and how to use them. So section 5, statistics. This is a print screen of the first page. And then the second page goes up to objective 10. And the third page up to objective 14. So we have 14 objectives in this section on statistics. Those 14 objectives have been divided into 17 videos because 1 or 2 objectives would take more than 1 video. So we have 17 videos from this section. We are now at video 1, objective 5.1, sample and population attributes. Now note also that this section is of particular interest and importance, as you will have to make use of many of these concepts in your SBA for mathematics and also for physics especially, and chemistry too, and maybe some other subjects like principles of business, where you would have to do analysis and interpretation for your SBA. After you collect the data, you analyze the data, and then you have to most likely prepare a graph and interpret or extract other information from that graph. So as I said, we begin here. Objective 5.1, differentiate between sample and population attributes. And the explanatory notes that CXC give is this: sample statistics and population parameters. Now, the truth of the matter is that is not enough. So firstly, we will do an overview of some statistics that you already are familiar with as an introduction to this section. And then we will return to this objective, which is not quite clear since a few examples would have helped greatly, like an example or two of what you mean by sample statistics or population parameters. With that in mind, I will do my best, which may be somewhat more than what is really required for this objective. But I will try to cover it, at least what may be required. So what is statistics? Statistics is that branch of applied mathematics that concerns the collection, organization, analysis, interpretation, and presentation of empirical data. In applying statistics to scientific, industrial, or social problems, it is conventional to begin with a statistical population or a statistical model to be studied, and that's from Wikipedia. Another way to look at it is that statistics help us understand data by summarizing, analyzing, and interpreting information. Statistics can help us identify patterns, make predictions, and support decisions. Here are some things that statistics can tell us: what is average, what is typical, how spread out the data is, whether groups are different, and whether variables are related. Some good ways that statistics are used: 1, to help governments, businesses, and organizations to track progress, analyze problems, and prioritize. Another way is to help us make informed decisions. And thirdly, it can help us support arguments in research papers and presentations. How are statistics gathered? Often by studying a sample of a larger group. This is because it is often too costly or difficult or even impossible to gather data about an entire population. Warning: statistics can be misused. Here are some examples. One, cherry picking data, which means that you select data that supports an argument while ignoring contradictory data. The second way, misleading graphs. Example, the y-axis does not start at 0. And 3, faulty correlations. Two variables appear to be linked, but the connection is not causal and is due to a third confounding factor. Example, you may notice that higher electricity costs parallel higher education costs. And you could say the higher electricity costs cause the higher education costs, when in fact, both are due to inflation. So the information gleaned from statistics generally are good, but it can be misused. So we will begin with some statistics that you already know as an introduction to this section on statistics. If you look at this table here, it shows a list of all students in both Forms 4, that is Form 4 Science and Form 4 Physics, in a hypothetical school, and their marks for the end of the academic year 2023-2024. So you have registration number here, surname there, first name here, sex, class, marks for certain subjects. Over here, total marks, number of subjects done, average, pass or fail, position or rank. And then you have, for the details here, number of females, number of males, and so on. Now, what you have here is called data. It is raw, unprocessed facts. That's data. Now, if you do any calculation on this data, you have now produced information, which makes this data meaningful. As you look at it here, it is kind of confusing. So we will do some calculation on this data. Firstly, we will find total. We can insert in this spreadsheet the sum function. We add up all the numbers from F3 to N3. And so we get this total here for the first person. We drag that formula down. And now it is making a little more sense. We now have some information, not much, but some information. The data is somewhat meaningful. For example, you could see that this first person here, Alan, got 387 marks. And let's take this other person here, Beverly, got 396 marks. As it stands here, it may look like Beverly has more marks than Alan, which is true. However, if we leave it as that and say Beverly did better than Alan, that's not a true picture. We have to do something more. So let's now go and deal with number of subjects done. Before we get to that, if you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. So now let's get back here. Number of subjects done. Now we have a little clearer picture. Again, we can add a function here. This is spreadsheet, Excel, Microsoft. So we count from F3 to N3. That is from there to there. And we find that this first student here, Alan, did 6 subjects. And also that Beverly here did 7 subjects. It's a little more meaningful. Now we will find average and get a clearer picture of what is happening with that 396 for 7 subjects and 387 for 6 subjects. We find the average percentage. So we now divide this by that, express it as percentage, and to get these numbers here, you'd have to divide by 100. Now the data is much more meaningful because we have some information based on the data. So we look at the first student there, Alan. He did 6 subjects, got 387 total marks, and an average percentage of 64.5, whereas Beverly did 7 subjects, got more marks, 396, than Alan, but when you divide by the 7 subjects, percentage is 56.6. So now we are getting a clearer picture of how Beverly did in comparison to Alan. Let's zoom in on that. As we said, this 387 and 396, at first glance, the 396 looks better. But when you consider that that student did 6 subjects, this one did 7, and you find the average, you find that this average is 56.6 and this average is 64.5. So in effect, this first student actually did better than the second one. Alan actually did better than Beverly, percentage-wise. Now we are also going to insert an if function, and we will say if Q3, that is if this number here, is greater than or equal to 60%, that will be a pass, and if not, it would be a fail. We are using 60% as pass. And we drag the formula down, and now we get some more information. It is now much more meaningful. You can see that this first student here, Alan, passed, whereas this next student here, Beverly, failed. Since we are using 60%, now, of course, if you were using 50%, then both of them will pass. Also, we can now insert a function here to find the rank of each student in the 2 classes together. So we insert a rank function, and we are going to rank this first percentage here, which is Q3, in this range, that whole range there. That's why we use this $ here to show absolute addressing. That 0 will give the highest mark first position. If we had 1 there, it will give the lowest mark first. But with this 0, we're able to do it the regular way. Highest marks would get first. So we looked at that, and we see that we have this student here, Alan, came 9th in the 2 classes, pass with that percentage, whereas Beverly got more marks, but because of more subjects, her percentage is less, and she failed, and she came 24th in the class. Now, if you leave it like that, it would be somewhat deceptive. This information is misleading because we have 2 separate classes here. We have business and science. So now we will have to separate the rank by business and science. Before we can do that, we will have to do a sort, separating out the students in class, but we are doing compound sort, and then secondly by sex, third by pass or fail, and fourth by position, to get a better picture of what has happened in this class. So this is the compound sort, first by class, then sex, then pass or fail, and then by position. Once we say okay, this is what we have. Notice that the students are now separated out into business and science, and then the business students are separated out into females up here, and then males Down here, same thing for the science. And then for the females, you now have fail and then pass and their rank. And the same thing for the male in business, fail and pass. Well, we do the same thing for science, female, fail and pass, male, fail and pass. So we are able to do that, but we still have a problem. It's much better, but we still have one problem. And the problem is everybody is ranked together in one class. We have to separate out that ranking in business and science. So we will change this rank based on class, and now it looks like this. Students now ranked in class. That's the business student, science students down here, business student up here, science students down here. Note that Alan, when ranked with the other class, was 9th, now he is 8th. And Beverly, when ranked with the other class, was 24th. Now she is 11th. And be careful with that, because that 11 may look good until we look at number of students in these classes, which we will come to just now. So now the students are ranked by class, but we are not quite finished with this statistics page yet. Let's derive some more information to get a better idea of how Form 4 did. So what we will do, we will add down here under each column of marks, we will add the mean, we will add the highest, which is maximum, the lowest, which is minimum. We will also find what the standard deviation is per subject, and we will also include here number of females, number of males, number of business students, number of science students, number passed, number failed, which is this page. Now, as you can see, for IT, the mean is 70.2, the highest mark is 83, the lowest mark is 56, and the standard deviation is 7.9, which means that with such a small standard deviation, the marks are bunched together closer to the mean. In contrast, if we take math, the mean is 60.4, the highest is 85, the lowest is 61, and now the standard deviation is almost 16, which is about twice as the one for IT. So now the marks are further separated from the mean than they were in IT. And we'll get back to that later on. You don't have to actually calculate this, but you do need to be able to use them like I just did in terms of how close the marks are to the mean. Now, I put in a COUNTIF function here. COUNTIF, this column here has this column here from R3 to R30 if it has the word pass in it, and we got 18 persons pass, and of course down here it would be those that fail. And over here, COUNTIF, that column up there has the word female in it or male, and then for business, 4B or 4 science. The same COUNTIF, just the range differs. So now we have a much better idea of how Form 4 students did in this exam, both individually and subject-wise. Now, one more thing before we go to graphs or charts, and that is a summary of this sheet. Summary of a larger table, and this may be new to some of you, and this is a summary here that we have. It is called a pivot table, and this is one way of organizing the pivot table for this sheet. The highest level is based on class, and then female, male in the different classes, and then fail, pass, So let's take a closer look at that pivot table. So as I said, a pivot table is a summary table of a larger table. If you had only this table, this pivot table, what can you deduce from it? What information can you extract? Well, first of all, you know that there are two forms, 4, B, and S. You also know that Form 4 Business has 17 students, 10 females and 7 males, 17 students, 10 females and 7 males. You also know that Form 4 Science has 11 students, 6 females and 5 males, 11 students, Form 4 Science, 6 females and 5 males. You also know that in Form 4B, 6 females passed and 4 females failed. That is here. That's Form 4 Business for females. And you also know for the males, 5 passed and 2 failed. You can also deduce that 11 students passed in Form 4B. That is to say, this 6 here plus this 5 here, those 11 passed, which is 65%, because it's out of 17. And of course, 6 failed. And so on. We can deduce more information. We haven't touched Form 4 Science yet in terms of details. But this is what you could get from a pivot table. So these are information that you could get from a pivot table. While these statistics may be helpful with details, graphs may give a better understanding since it's a picture. First, you will have to do pie chart, and we will do the pie chart based on that pivot table, which looks like this. And I'm sure you have seen something like this before. Later on, we will learn how to do that in Objective 4 in this section. Essentially, 4 Science male pass 11%, 4 Science male fail 7%, and the same thing goes for females, so 4 Science. And then we come to Form 4 Business, male pass, female pass, male fail, female fail. So it is showing the same information graphically, and it's easier to understand. Then we will look at column graph. This time we are only looking at Form 4 Business students comparing their math and IT. The blue is math and the red is IT. As you could see at a glance, most students did better in IT. The red column is higher for most students than the blue one, but there are also 1 or 2 students that did better in math than in IT. For example, this student here, Rosalie, and this other student here, Michael. So that's a column graph. Now, if we rotate that column graph horizontal instead of vertical, you now have what is called a bar graph, which looks like this. Very similar to the column graph, except that it is rotated 90 degrees to the right and is now horizontal instead of vertical. A line graph looks like this. Line graph. And this is just the math marks for both Form 4 Business and Form 4 Science. Now, if you are told that the mean, which we sometimes call average, is 60.4, draw that line on this graph. You just go a little above 60 here, draw that line in there, and that is the mean. As you could see, the scores vary quite a lot above and below that mean, which gives an idea of our standard deviation. It varies quite a lot. If we compare that with what happens with the IT marks for both Form 4 Business and Science, you will notice now that if we put in the mean, which is 70.2, which is that line there, that the scores don't vary quite a lot, higher or lower, from that mean. They are bunched closer together. Therefore, the standard deviation of this will be much less than the one for math. Now, Objective 4 in this section says you are to construct statistical diagrams. Pie chart, we look at an example of that already. Bar charts, line graphs, histograms are somewhat similar to bar charts with some little variation. And frequency polygons, you derive that from your histograms. So we will learn about all of that in Objective 4. We will divide it in 2 videos, pie chart and bar charts, and then the rest in the follow-up video. Now back to this first objective. As I said, we begin here. Objective 5.1, differentiate between sample and population attributes. And the explanatory notes that CSEC gave is sample statistics and population parameters. As I said before, this is not quite clear, so I will do the best I can, especially with this population parameters. This one here is easier to deal with. So how are statistics gathered? As we said before, often by studying a sample of a larger group. This is because it is often too costly or difficult or impossible to gather data about the entire population. And by population, we do not necessarily mean people, though we can mean that as well. We could also mean anything else, example, cars or outboard motors or anything at all. So we are to differentiate between sample and population attributes. So let's begin with population attributes. As I said, it would have been helpful if CSEC had given 1 or 2 examples so we know exactly if we are on the right track. But without that, I will do my best. Population attributes are summaries of characteristics of the population. Formally, an attribute is a function applied to the entire population. Now, you may not understand that, but hopefully, as we go along, it will be clearer. So we are to differentiate between sample and population attributes. So let's talk about population attributes. In statistics, population attributes refer to the characteristics of individuals within a population, such as their age distribution, sex ratio, birth rate, death rate, and population density, which collectively paint a picture of the population's structure and dynamics. Essentially, they are measurable features that distinguish one population from another, say the population in Barbados as opposed to the population in Guyana. So key population attributes include, but not limited to, now this is what we're looking at. 1, population size. That's self-explanatory. 2, population density, the number of individuals who live on average per unit area, say 1 square kilometer. Age distribution. So the breakdown of individuals across different age groups. Let's say children under 12, youths 12 to 18, young adults 18 to 30, 40, and so on. So age distribution. 4th, sex ratio, the proportion of males to females in a population. 5th, birth rate, the number of births per unit time per capita. And the last one we will be looking at is death rate, number of deaths per unit time per capita. So those are some population attributes. I don't know if you have to memorize them, or all you have to do is state what the difference is between population attributes and sample attributes. But these are some population attributes applied to the whole population. Now, from that population, if we want to find out anything about, let's say, a country, we will take a sample rather than the whole population. So now let's talk about sample attributes. It is a subset of the population or from the population. A sample must be representative of the larger population whose particular characteristics you want to investigate. It must be representative. That's the main thing about a sample. And how do you get that representation? One, it mirrors the key characteristics of the population that we were just looking at. Two, it is randomly selected to ensure that each member has an equal chance of being chosen, that each member of the population has an equal chance of being chosen for the sample. And three, adequate size of the sample to provide reliable results. For example, if you're studying, let's say, the whole country, you can't just pick 10 persons randomly. So we said sample is a subset from the population. It must be representative of the larger population. Let's go back now and look at each one of this. Let's go back and look at each one of those three characteristics of sample. One, mirrors the key characteristics of the population. So don't compare apples with oranges. That would be a category fallacy. As an example that is way out, if you want to study the study habits of, let us say, Form 4 and 5 male Indian students in Trinidad, don't do a study on all students in San Fernando, which is a city in Trinidad and Tobago. Your result from that study will not be applicable to this one. That's a way out example, of course. And here is another way out example. If you are doing research on fish growth, salmon in net cages in the ocean, you compare that with fish growth of tilapia in ponds in fresh water. Those are two completely different situations. Again, any conclusion you draw will be totally wrong. Secondly, randomly select to ensure that each member has an equal chance of being chosen. Now, this one is extremely important. Now, there are two categories of sampling that we can use here for random. One is called probability sampling, and in this case, you can actually calculate the probability of any single person in the population being selected. And the other one is non-probability, and that explains itself. We take a closer look at probability sampling. The first one is called simple random sampling, SRS, which occurs when each member of the population has the same probability of being chosen for the study. You could think of this as the lottery method. Place everybody's name in a bag and blindly select however many people you want in your sample. We come to size just now. The next one, we are still on probability sampling, is stratified sampling. Now, this is a variation of the random sampling we just looked at. It involves dividing the population into distinct groups or strata, maybe age. And then once you have the strata, you use the simple random method. So it's stratified sampling. Thirdly, you can use systematic sampling, where researchers reference a list and choose a certain subgroup as study participants. For example, you can compile a list of 3,000 individuals in a population and then choose the 10th person on that list. So we looked at three methods of probability sampling. There are two others which we will not spend much time on, just to let you know that there are two others: cluster sampling and multi-stage sampling. So let's move from probability sampling to non-probability sampling. One is convenience sampling. Researchers choose random people as testing subjects. Example, a group of people walking by on a street. The researcher has no control of the sample group itself. This type of sampling is both cost and time effective. So you save money, you save time. It's not very good. Second is quoted sampling. Now we are, remember, non-probability sampling. Creating a sample based on a pre-defined traits. For example, the researcher might gather a group of people who are all age 65 or older. This allows researchers to easily gather data from a specific demographic. And I think that should suffice for random sampling. We looked at probability and non-probability. Which one you choose would depend on how much time and how much money you have. My estimation, the best one is stratified sampling. Now, one more sample attribute that we need to look at is the size of the sample. Whatever the population is, you have to get a reasonable size that represents that population. In general, larger sample size are better because they are more accurate and reduce the risk of sampling errors. However, there is a downside. Larger samples can be more expensive and logistically more challenging. So here is what you need to know. For populations under 1,000, a minimum of 30% of the population is recommended. For larger populations, let's say 5,000, 10,000, a million, a minimum of 10% of the population is recommended. CSEC didn't say that. This is what I have found from research. And thirdly, if the population is really, really small, as in the less than 30 students we had in the marks we were looking at from Form 4 Business and Science, then it may be best to consider them all. You're not going to pick 5 students out of 30. Take all 30. However, if you have, let us say, 500, you take 30% of that. So that is the sample size. So when we look, so let's summarize what we have just said. We need to differentiate between sample and population attributes. In its simplest term, a population attribute is a function applied to the entire population, like size, 5 million, while a sample attribute is a characteristic of the sample, like size, 300. Population attributes, we talk about population size, population density, age distribution, sex ratio, birth rate, death rate, and there are some others. Sample attributes, there are 3. Mirrors the key characteristics of the population, randomly selected to ensure that each member has an equal chance of being chosen, and it must be of an adequate size to provide reliable results. And that should suffice for this objective, as well as an introduction to Section 5, Statistics. So that brings us to the end of video 1, based on Objective 1 in Section 5.